Hello and welcome to PMCD Maths Teaching, and in this session we're looking at sample space diagrams. And as usual, I'll give you the rationale for the way that I'm approaching this, and here it is. So if you want to read this in further detail, then you can just pause and read that. Otherwise, I'm going to carry on. Okay, so if you've read this, you'll see that the way I approach this is all about using what I think pupils are interested in or would find exciting. And again, it's engagement straight away. Again, there's this big thing about engagement. Engagement in itself doesn't mean good learning, but if you can trigger their enthusiasm and their curiosity, you're going to make bigger strides when you get into the learning phase of the lesson. And I truly believe that as well. So here's the sequence for teaching. And these first ones here, the odds, evens, factors, multiples, and primes. That's if you want to ask questions involving those. And I think it's a good way to revise what you're doing as you're going along. Properties of fraction, decimal, percentage. You can ask for it in any form there that you like. And this leads on nicely to the and rule for independent events. And then obviously you can go on to tree diagrams once you've dealt with the or rule for those events. So, okay, so where did I start with this? Well, I normally start with very famous game, the rock, paper, scissors. Okay, now ask them, do they think there is a strategy for winning this? And explain their answer first of all. So the whole idea is there a strategy? Have they got a hypothesis for how to win rock, paper, scissors? And some of them think they will. And we're not talking about mind games here. We're just talking about, is there a choice that they could make that they would win more often than others? And, we can make a little tally at the start of the lesson. I've done that on the board before. How many people think rock, paper, or scissors? How many think there's no strategy? And then what the idea is, we're going to look into this and analyze it and see mathematically what is the truth here. So I get them to say, play 12 times and keep a tally of the winning move, rock, paper, scissors. And they answer that question after that so that they can start seeing. Now, this again exposes the fact that even though probability is theoretical, in practice, it might have been that paper won most of the time. Okay, now I again can put this on the board. We can take this from the whole class if you've got time, very, very quickly. How many people with rock won? How many times did rock win? How many times did paper win? How many times did scissors win? So we can see what's happening here. And this may work out to be the ones that they look all even. It may look like one has a higher probability of winning the other. Okay, so once we've done that, what I move on to then, so they've had a little bit of time to get their energy out playing this, and they do enjoy this. What I ask them is to list all the possible outcomes of a game. And I'm asking them here, I'm starting to get this focus about being systematic. Okay, so, and we discuss what being systematic is, because obviously we know that's a useful skill when you're approaching mathematics. If you go random, random listings, what's going to happen is you're either going to duplicate or you're going to miss one of the outcomes. So what I would be saying here is rock, scissors. For me, systematically, I would say we'll call that R, rock, scissors, rock, paper, rock, rock. And the winner, rock and scissors, would be rock, rock, paper would be paper, and this would be a draw. So I've done everything with rock as player one. Now I'm going to do everything with player one with scissors. And that's being systematic so they can get all the outcomes. And this is sample space diagram in itself. Okay, explain what sample space means. Okay, what does sample mean to them? Okay, sample space is that if we took, sometimes they think about music, I suppose. If you've got a music track and you take samples from it, you're only taking, so this is the whole track, it plays for this amount of time. If we take a sample out of it, we only take one part of that track. And that might appear in a song. If we took all possible samples, you'd have all the possible outcomes that we could get from taking parts of a song and feeding it into another track. So it's the same idea here. We're writing all the possible outcomes. All the possible outcomes, if we write them down as a sample, and the sample space is the space in which we show all those samples. This might seem, I hope I'm not patronizing this way, but the point is, it's very easy just to get straight into the maths and not explain the words. And students will be sitting there with this words buzzing around. What does that mean? Sample space. And it's just another thing that adds to that mystery of maths. And maths is hard because lots of different words. If we decode this as we're going along, life becomes much easier for the students and for us in the end, okay? So I said there must be an easier way. I suppose I should say another way, not an easier way perhaps. But then it's about showing, because there's only two possible outcomes, how we can use a two-dimensional sample space diagram in this way. So I was going to show them how to do this. We're going to draw a sample space diagram in this way as well. So we've got two versions of this. Player one could be rock, paper and scissors. Player two could get rock, paper and scissors. I'll explain the codes afterwards. You don't have to use those. Depends how you want to go about this. And what we're going to say is I'm going to put player one first in my ordering. Now this is important. Otherwise we'll get things that don't look right. Paper, rock, scissors, rock, rock, paper, 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 scissors, paper, and rock, scissors, paper, scissors, scissors, scissors. It's important here because otherwise what you'll get, and this is the question you're going to have to watch out for here, is aren't these the same thing? I mean, this will happen in this listing as well. In this listing here, okay? You might get rock, paper, and paper, rock, and they'll say, oh, isn't that the same thing? Well, this is great because you can actually, they've physically done this game. It's not something you talk about and try and imagine. They've actually played this game. If player one has got rock and player two's got paper, is that the same, physically the same thing? If I filmed it, would it look the same as player one having paper, player two having rock? They are different outcomes. Very important point, otherwise they'll count them as the same thing. They're physically different things, so we have to list them differently. And it's the same here. Player one, paper, player two, rock. Now, if we don't get the order, if we're not strict to say I'm going to put player one's letter first, you may end up with RP and RP there, and then you've got all sorts of confusion. Okay, so I'm just going to undo that. There we go, because we'll need this in a way. So how many outcomes are there? Well, it's easy to see there's how many outcomes there are. We've got 9. And again, with listing, you're more chance of making errors when there's two possible two players in this case playing. How many ways can player one win? So we write the way that player one has won. And this is you don't need to use this, but this is my idea of really how to show that player one's winning. So player one will win when, for example, scissors, rock, paper, rock. Player one would win here. So I'm putting player one's code there. Player one would win at what we got: rock, paper, no, paper, paper, scissors, paper would win there. And player one would win on this row: rock, scissors, no, paper, scissors, rock, scissors, rock, scissors. Sorry, rock, scissors. Yes, it's there, isn't it? Okay. Player two, we can use the triangle, or we could use a circle. I suppose it would be better, wouldn't it? A circle. Scissors, rock. Rock would beat scissors, wouldn't it? So we'd end up with that one there. Rock, paper, paper wraps around rock. So that one there. I should use a different color. And paper, scissors, paper, scissors, paper, scissors. Who wins that one then? Scissors, paper. Yeah, player two. Okay, and what have we got left in the middle then? What we've got left in the middle are these three, which we can see are the draws. Okay. Now, the reason I've done this, you can see first there's a nice little symmetry in this diagram. That they find that quite interesting. How many ways can player one win? Player one can win three ways. What's the probability that player one will win? 3 chances out of 9, 3 ways out of 9, which can be simplified to 1 over 3. Same thing for player two, we get 1 over 3, and probability to draw 1 over 3. So all of a sudden we say, well, go back to the original question to start the lesson. Is there a strategy? If you're choosing randomly, there is no strategy to win. It is a game of chance. We've got an equal chance of winning, losing, or drawing there. Okay, so this is quite revealing for some students. They might have sensed it, they might have had that intuition idea, but now they've got the mathematical analysis to back this up. And that's quite exciting. So what do we take this next? Well, then it's a bit of practice of this, really. And you can see I've thrown in those, you make your own examples here. I do tend to try and use pupils in the class, just spread that around. It's just a nice little touch, I think, to personalize it for my class when I'm doing this rather than just something separate. This might be part of a game, okay? This is the context for this. And you're bringing in prime numbers, multiples, and factors. So hopefully they're confident with those. And then I move on to 2 dice. Okay, so this is quite a big one. And what we're looking at is totals now. So we have to have dice 1 and dice 2. Very important to label these. And again, the ordering is important. Okay, the ordering is important. So I'm putting dice 1 first, 2, 1, 3, 1, and so on. Okay, I mean, you'll have done this before, no doubt. Okay, but I'm getting them to do this so they can see what the probabilities of each number are. And then obviously we're trying to work out there's a lot of lovely symmetry in this diagram actually as well. Okay, so you will see that very, very nicely, and they can use that to find probabilities. So by circling how many totals we get of 2, totals we get of 3, totals we get of 4 as well. So once you've done that diagram, you get, like I said, you get this lovely, I couldn't fit it in there above there. So 1, 2, 3, 4, 5, 6. Okay, totals go from 12 to 2. So you've got this discussion of why can't we get a total of 1? And you should know that obviously that 7 ends up being with the most common total because it's got the most combinations that make that total. But you'll see all sorts of symmetry as you're going through this diagram. So I'm not going to go through this. You can do this yourselves here. But the probability of 7 is the highest probability. The next one is 6 and 8. Probably getting a total of 6 or 8 is. And the reason we're using this diagram is they've got this. They can use this then to go into what I think is, a really good way of analysing how to play Monopoly. So we know that the most common totals are 6, 7, and 8. Okay. Now it's up to you how much you reveal about this. You may not reveal that. You may just leave them and let them fill out their sample space diagram. So, okay, can you come up with a strategy to improve, or where should hotels be built to improve your chances of winning a Monopoly if you're playing this? Okay, now the approach and there's lots of different approaches here, but the chance cards, we've got to go to jail, advance to nearest utility, advance to go, and there's also one that takes us to Trafalgar Square. So there's a lot here, but if I just look at those 3, jail, let's look at jail, okay? If we get 7, then you start seeing the genius of how this game was created, actually. 7, if you go to jail, you've got 2 options. You can either pay or you can roll a double. Okay, if you don't manage to roll a double, you're going to have to, the next roll you get will take you out of jail. So let's say you've had to pay your way out of jail. The most common total you're going to get when you roll the dice is 7. So let's look at it. 1, 2, 3, 4, 5, 6, 7. That takes you to the chest. Okay, so you can't build a hotel there, can you? But this is where it gets interesting. What's the next most common number to get would be 6 and 8. So for me, I'm looking at yes, please, I want those 2 properties. So that's going to give me a bit of an edge. All these marginal gains are going to add up in the end of the day. Okay, where else? Go, advance to go. That's quite a good one. 1, 2, 3, 4, 5, 6, 7. Oh, look. See, there's no coincidence here, is there? That 6 and 8. Yeah, I want those properties. Where else? Where else can we go to? Nearest utility. Let's take the the electric company. 1, 2, 3, 4, 5, 6, 7. 7's actually there. That's a nice one. These cards don't come all the time. But jail comes up quite a lot, doesn't it? Okay, you've got 2. You've got that the go to jail square. So orange is looking good. Also the waterworks. 1, 2, 3, 4, 5, 6, 7. So that's station maybe. And 6 and 8 as well. Okay, 8's there. So looking at these green ones over here. So Bond Street, Regent Street, etc. And there is one more actually at Trafalgar Square, which I haven't written there. Okay, you can go into this in more detail as well. 1, 2, 3, 4, 5, 6, 7. Yes, 6 and 8. Okay, so I'm seeing a strategy for myself here, how I would go about playing this. Now, look, I've done this, and it doesn't always work because probability is probability at the end of the day. But over a long period of time, we know this would be successful. Now, obviously, you let them find this out, but this is my hints for what to do. And this can take up, 1 or 2 lessons, I think. If you do it in full, depending on how quickly they get on with the task to start off with. But a nice way to look at it. If you come up with other ways to analyse this, I'd be really interested because I think going again for something that's familiar to them really makes a difference to how they enjoy the lesson, what they remember. What I said about making these lessons memorable. years to come, they might remember, oh, I remember we did that lesson where we tried to work out how we could win Monopoly. I mean, as a teacher, when you hear that, that's probably one of the warming things you can hear. Anyway, I hope this gives you some ideas. Maybe you've got your own ideas of games that you can analyse in this way. I'd love to hear about those in the comments. But for now, that's it for now. I hope that you got something useful out of that, and I will see you next time. Okay, thank you.